Hi there, this is Arun Gupta. I'm here from DevOps Belgium with Roy and Tim.
Hello.
Hey.
Hello. So you guys gave a talk this morning. It's a mouthful title. Easily finding your conference pictures using the power of the cloud.
It's a mouthful.
All right, so why don't you introduce yourself first?
Well, I'm Roy. I work for JPoint, small consultancy company in the Netherlands. We work for different clients, bigger clients, banks, etc., financial institutes. So yeah, that's me.
Yep. My name is Tim. I work for JPoint as well. Same type of clients.
All right, very cool. So tell me about this talk. What was this talk about?
Yeah, so our talk was about a pet project that we did with JPoint. We at a tech weekend. We spent some time on using the power of the cloud. We did a couple of projects, and one of these projects was face recognition with AWS recognition.
So tell me more about it. And what did you? So what was the input? What was the output?
Yeah, so the input was in this case a Flickr album. So we inputted a Flickr album with the Flickr API, and we just searched by photos. So by faces that we recognized on pictures.
Yeah, it sort of came to be when we spoke with Stefan from DevOps as well. I mean, we go to plenty of conferences, and it's nice to have pictures, but you always go through dozens of pages trying to find pictures where you're actually on, right? So at first it started for us to use it for ourselves, and then we spoke with Stefan, and he told, well, I need something to find pictures of my speakers to promote the event. So basically we could leverage it that way.
Very cool. I mean, this was a necessity, and that's where you innovated on top of that.
Exactly.
You talked about AWS. So what AWS API did you use over there?
So the AWS API that we used was for the image recognition was recognition, but we also used the lambdas for the functional serverless stuff. What else do we use?
So DynamoDB, SQS, that sort of
let's
stuff.
talk about the stack, overall stack. So how was the application composed of?
Yeah, so basically it had to be cheap, so to say. So when it's not doing anything, it shouldn't cost anything. So we chose for a serverless setup, right? So we chose for lambdas to execute our functions, and we chose for, well, basically the best of breed services in the cloud which were cheapest to us. So we had a very simple data model, very simple needs for data storage. So we chose DynamoDB to store our data. We chose SQS to decouple our lambdas because we didn't know how our architecture would evolve, actually, because we did not have that much experience using or building serverless architecture. So that way we could, well, basically refactor without too much trouble.
Right.
So yeah, and it all revolved around this AWS recognition service. So it was easiest to do it in the cloud.
Tell more about the recognition. So what is the recognition service?
Yeah, so recognition service is basically a deep learning service provided by AWS, which can be used to for video and images to do all sorts of stuff like object detection, celebrity recognition, checking for unsafe content, and some other stuff as well, but also for facial recognition. So here's the face in the picture, it has these characteristics, and it allows you to, when it has indexed faces on pictures, to actually tell it, well, search for the face in this picture in the set that you already have, and tell me which pictures contain this face.
So that's the Flickr album that you fed to recognition is your training data, basically.
Yeah.
And now you are saying, based upon that training data, recognition API for your AWS account is ready to understand, I have a pre-trained model in the backend, which you didn't have to do because all you used was the AWS recognition API and Flickr API, and your model is ready. So there is no need to learn machine learning in that case.
Exactly.
Correct.
Exactly.
But you're still getting all the value proposition of machine learning.
Right.
Using the power of the cloud, right?
Using the power of the cloud. That was the tech weekend about.
Exactly.
Fantastic. So, got the part of Lambda, got the part of DynamoDB, got the part of recognition API. What else were involved in the stack? What else? What other components?
Well, like I said, we were looking at a solution that would not be that expensive. So we started looking into, when we're building lambdas, we want to build them in Java because that's that's what we do. We build software in Java. We can also write JavaScript and that sort of stuff, but it's not really the thing that we like. So we like to have it in Java. But then one of the downsides that you often hear about lambdas written in Java is that they are a bit slower, a bit heavier.
There's a cold. It's a JVM thing,
Yeah, right. Yeah, exactly.
It's a cold boot. It takes time, particularly during the startup.
So we decided, well, if we want to do this, we have to look into technologies that will make this easier or better. So we started looking into technologies like GraalVM, like Quarkus, the stuff we've seen talks on in the previous 1.5 years, and that we said, well, this could reduce startup time, this could reduce the memory footprint, and therefore allow us to use smaller lambdas, lesser cost. That was the basic
So why
reasoning.
not use Quarkus by itself as opposed to in a combination with Quarkus and Graal VM together?
Yeah, so if you look at I mean, mainly we used Quarkus as a framework because it facilitated us in using Graal VM. So Graal VM was actually the thing that we wanted to use to build a native image, right? So have it faster, smaller heap, that sort of stuff. And Quarkus actually allows us to have build tools to do that. And because we wanted to run it in Lambda, you still had to provide your own custom runtime. So you have to have the interface to actually let the Lambda be called by AWS when the function is called. So Quarkus offers a plugin for Amazon Lambda that takes care of that integration layer. So that was basically the reason for choosing those two tools.
So your ultimate goal was to get to a Graal VM, and the way you got to the Graal VM is using the Quarkus API, and because Quarkus provides a Lambda integration as well, and that really led to that, and then you basically use a custom Lambda runtime over there to integrate with Lambda over there.
Correct.
And going back to your philosophy that you want to keep it cheap, that actually gave you cheap.
Exactly.
Now, tell me about the native image a bit more. You're using Graal VM to create a native image. How is that different from a Docker image?
Well, basically what you build is a binary, right? So you build a binary that can be executed in, well, any environment. And well, with regards to the Lambda runtime, it just basically it calls the native function, and it will start up and it will run. It's not that we oppose to using Docker, for example, but our reasoning was we use Lambda because then we do not pay when it isn't used, instead of, for example, a container service that we could have used as well.
Right.
And this was, well, in our vision, the easiest way to do it.
Right. Okay. Okay. And how did you deploy the entire service? Now, you're doing Lambda, you're doing DynamoDB, you're doing SQS, you're doing custom Lambda runtime, you're doing all sorts of builds, Graal VM. How did you deploy? What was your build infrastructure look like?
Yeah, so we used the CDK for that.
So what is CDK?
So CDK is the
Cloud Development
Cloud Development Kit, right?
The abbreviation is a bit,
yeah. Thanks. So yeah, for us it was like it's yeah, like Tim also mentioned in the presentation. It's like when you say infrastructure as code, then you expect to code your infrastructure.
You really expect code, not JSON or a YAML.
Indeed,
exactly,
right?
yeah.
You don't want configuration
Yeah.
as infrastructure as configuration, right? You want to code really, and now with the CDK, it really becomes available that you can actually use all the benefits of your tools, your EDA, etc., to code your infrastructure.
So you can basically do a layer, which is a Java layer, or there's a multiple bindings as well of different languages.
Correct, yeah.
In your case, you wrote the CDK code in Java.
Yep. Yes.
And how did that blend it? So your infrastructure is a code, your application is a code, all of this combined using Maven, Gradle, what was it?
well, basically these are separate projects, so we are still deploying infrastructure separate from Lambda. So we build our Lambdas, we upload them to S3, and then we have the CDK defining, well, these functions are there, and you use this source for the Lambda function.
So CDK kind of becomes your binding function
Exactly.
between the actual AWS resources and your application code, and binds them together.
Yeah, and it's, I mean, for us it was a treat to use it, because we've always been hassling with these big JSON or be it YAML files or whatever. I mean, it's just not nice to work with, and then you have to configure all these access rules, right? Because we are dealing with a subject which is, of course, privacy sensitive. So we have a short time in which we have to download a picture from Flickr to Amazon to be able to import it into Rekognition. When that is done, we remove it because we do not want that data, but it's still there, so it needs to be protected. And then you need to hassle around with the security groups and that sort of stuff. And that's normally well, in my experience for the past 5 years, that's quite a task. And this way you can basically just take your object that you have, right, representing the S3 bucket, and tell it, well, this function, you read this function, and then bam, all the stuff is handled. So it makes it so much easier for us.
It does make it easy to set up your infrastructure as a code, and because you're a Java programmer, as you said, you can start leveraging your IDEs and all those tools that are anyway available to you.
Yeah.
Fantastic. Now, is DevOps Belgium the first conference where you're using this face recognition?
Yep.
And what are the plans? What are the future plans?
Yeah, I think we can work a bit still on some things here. So we still have some points that we want to improve. Yeah, and then we'll see. I don't know.
We'd be thinking about, maybe we could productize it, right? Make a product out of it, but we're not sure yet if there's if there's really a market for this thing. I mean, you can put it in, you can use it for conferences, but you could also use it for festivals and whatnot. Everywhere a large set of pictures is where people are on. So that's interesting. But then we would have to make it. I mean, now the software that we write is relatively simple. I mean, all the heavy lifting is done in the cloud, so you can write it yourself as well. I mean, it's not that hard. But when we would look into additional features, right, like for example, implement the right to be forgotten in the GDPR regulations,
right.
You could leverage a tool like this to actually say, well, I'm on these pictures, there is my face, then blur this part of the picture out. So that
you can actually blur only that part of the picture, just that particular face.
Right, exactly.
Yeah. Any surprises when you were actually doing the recognition across the board?
Yeah, well, a lot of surprises actually, because we had pictures of the crowd in DevOps, and then there were people recognized in the crowd. Well, we couldn't even find them, so it was really hard to find them, and we really used the recognition to show us where it was, because otherwise we couldn't find it. So it was really
right. And I was
awesome.
looking at the demo this morning in your talk, where you were saying, okay, show me the rectangle where the face is,
right.
And particularly Bird-John pictures, it was like from the side in a mirror reflection, and nobody would have ever guessed it. And we know his receding hairline, but not the face.
no, exactly. I mean, that was. I mean, I looked at the picture, and you see the back of his head, and I was like, how could this service possibly be able to recognize him by the back of his head by giving him a mugshot, right?
Yeah.
And then it was the reflection that really gave him away.
Now, if I'm a conference organizer and I want to implement the same idea, you're telling me that the code is not open source at this point of time, and I'll have to rewrite the entire thing by myself.
Yeah, but if you're really interested, drop us a line and we'll get in touch, because I mean, we're not here for making a lot of money.
Right. Understood. No, I think that's a relevant point. So, like, if any of the conference want to really implement this, they can reach out to you, and hopefully there are notes in the conference. Well, what are your Twitter handles? How can they reach out to you?
My Twitter handles are Braam, so BRAAM.
And I'm Tim V. Eijndhoven, which is a difficult one because it's TIMVEIJNDHOVEN. So it's a bit long one, but just search the DevOps hashtag and you will see tweets flying by with my name.
Fantastic. So I think that's relevant. If anybody wants to run this project, they can reach out to you and collaborate with you.
Yeah.
Sure.
Well, I really enjoyed talking to you, and this was a great talk. Thank you so much.
Thank you very much, Arun.
Thanks, same.
All right, thank you. This is Arun Gupta signing off from here. Bye-bye.